Hello, and thank you for joining us today as we discuss how to better value your milk while meeting the sustainability challenges of tomorrow. So with this presentation, you will see how to deliver value to your milk to the last drop. My name is Uyen Bouhil. A little about myself. I am the Global Technical Sales Manager for membranes filtration and microparticulation, and I will be your technical host for this webinar. I have a long background in the food and beverage industry and SPX flow, covering numbers of technologies and applications. I am food engineer, and I also have a Master of Science in Process Engineering and Technology, as well as a master degree in biochemistry. My current responsibility are defining based on customer specification and business drivers the most relevant technical solution, supporting SPX customers to find out solutions in order to stay ahead of this growth and take advantage of new opportunities. During my time here, it is my goal to cover all the benefits of milk fractionation and discuss the best way to conserve energy and water, optimize efficiency and overall advantages to this range of technology. A few housekeeping notes before we get started. As an audience member, you will not have audio or video capability. Please use the Q&A feature to submit any question throughout the presentation, and I will answer as many as I can at the end. If we do not have time to answer them all, my contact information will be provided during the Q&A session, during the last 10 minutes or so of this session. So let's get started with a discussion on revolutionize your dairy production with advanced milk fractionation. Our purpose at SPX Flow is to improve the world through innovative and sustainable solutions. Today's agenda, we will have a quick overview of milk ingredients market forecast from 2020 to 2025. Way to produce milk ingredients, why and how we will use milk fractionation to obtain flexibility to innovate and improve your recipes. Key drivers for dry and wet ingredients. And finally, the SPX flow fractionation solution. On this slide, you have a quick overview of milk ingredients market from 2020 to 2025, compiling main ingredients as milk proteins, micellar casein isolate, whey proteins, and lactose. The milk ingredients retail market represents $66 billion USD and have a positive trends globally. It has a growth forecast with an average CAGR at 5.5%, with an acceleration in the coming years reaching a CAGR at 7.1%. At SPX Flow, we understand that quality, cost, and sustainability are the primary drivers for you as big players in the dairy industry. Our milk fractionation technology offers a complete end-to-end solution, creating a lean and green manufacturing. By reducing cost, materials, downtime, and utilities, by improving the plant consolidation with the optimization of the process, swelling production, fewer lines, by increasing the production equipment flexibility, and by reducing and improving the wastewater stream. As you know, the fractionation process has been around for centuries, originally used in the production of cheese or caseinate. But this traditional way to proceed have a big impact on the quality and functionality of your ingredients. With advance in technology and research, the use of membrane filtration to separate milk components such as proteins, lactose, and minerals has become a key asset for dairy manufacturers who want to get the most out of dairy products. With this new way to proceed, you will get fantastic benefits as it is a natural form with higher purity, functionality, and more digest. Of course, this gentle way offers great advantages compared to the traditional methods. But it is not the only one that you can achieve with membrane filtration. We can mention top 5 reasons why invest in milk fractionation is the most important things for future dairy manufacturers. Primarily is diversification. Milk fractionation allows you to produce a range of value-add products with the same equipment. Thus, a broader portfolio helps meet the various preferences of consumers and open new market opportunities. Secondly is increased profit. Milk fractionation adds value to the milk by creating higher margin products. Thirdly is enhanced competitiveness. Milk fractionation enables you to differentiate itself from competitors by offering unique and customized products. Being proactive to market trends helps you gain a competitive edge in the market. Fourthly is better utilization. Fractionation allows you to efficiently valorize milk at the last drop. This minimizes waste and maximizes resource utilization, leading to cost saving and improved sustainability. Fifth, and not least, is improved chain integration. Investing in milk fractionation enables you to vertically integrate its operation by bringing additional processing steps in-house. This control over the production process enhances supply chain management, quality control, and product consistencies. It also reduces the reliance on external suppliers and fosters stronger relationship with customers. Milk is an amazing and complex mixture of water, fat, proteins, lactose, minerals, and vitamins. Fractionation with membrane filtration technology separates milk into its various components, or fractions, providing food industry with the flexibility to create a wide range of products that meet specific nutritional, functional, and consumer preferences. The term membrane filtration is used collectively represent the separation process by employing specific membrane filters to concentrate or fractionate a liquid into two liquids of different composition by selectively allowing some compounds to pass while encumbering the others. So the liquid that can pass the membranes is known as permeate, and the retained liquid is known as the retentate. Here, starting from the skim milk, we will get casein in the retentate and ideal whey in the permeate, using microfiltration. Why the name ideal whey? Because it comes directly from fresh cow milk and it's composed solely of native milk proteins with a higher quality compared to cheese whey, which is derived from cheese industry subproduct. So next step is to reach the target concentration level and purity with the ultrafiltration. Milk ingredients such as, in this example, micellar, casein, milk whey proteins, isolate, and lactose can be manufactured in both wet and dry forms. How is milk fractionation possible? Liquid milk and whey are suitable for membrane filtration process thanks to low viscosity, contain a lot of water, and used to be high volume bulk materials. The milk components can be easily fractionated due to their size. You have small molecules or ions like minerals and lactose, large molecules or proteins including calcium phosphate, and microparticles or fat globules, somatic cells, bacteria, or large aggregate. And you can see also that the membrane pore size fall within 4 main categories: reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. So, with membrane filtration, we can separate milk and whey components into smaller fractions. Each fraction can be used as a building block for new and innovation recipes. How does it work exactly? So fundamentally, membrane filtration is a pressure-driven technology that uses specific membranes with different pore size. The pore size is indicated by a cutoff value for a particular membrane. In order of increasing pore size, membrane filtration methods include 4 technologies: reverse osmosis, nanofiltration, ultrafiltration, and microfiltration. So reverse osmosis is for concentration of virtual, all suspended and dissolved matter. Nanofiltration is for concentration of virtual, all suspended and most dissolved matter. Ultrafiltration is for concentration of suspended proteins and fat. Microfiltration is for concentration of bacteria, fat globules, and large proteins aggregate. As you can see, for the main milk components, membranes are usually in the ultrafiltration range. The ultrafiltration cutoff value allows components such as lactose, lactic acid, and dissolved mineral to pass through the membranes as fat and proteins or concentrate. To go further in this valorization, functionalization is also essential to unlock the full potential of your milk components. By modifying functional group of milk molecules, we can develop new property and behavior, opening a world of a new application and innovation, as if to be used to improve the texture, stability, and flavor of food products. One of the most significant and well-known applications is the microparticulation of the whey proteins that you can see in the schema processed on the right of this slide. So starting with the liquid whey from cheese or ideal whey from milk fractionation, we will concentrate the whey proteins through the ultrafiltration plant. The whey proteins concentrate will feed our unique SPX flow microparticulation technologies. Microparticulation will bring functional property used for dairy and food products, as a creamy mouthfeel, particularly in low-fat products, water binding, improve texture and viscosity, excellent emulsification properties, stabilizer properties, and of course, high nutritional value. In order to stay ahead of this growth and take advantage of new opportunities, dairy producers are continually seeking flexible and innovative ways for making the clean label product, and more sophisticated without compromise on taste and feel. It is the reason why SPX Flow innovate with a new concept of milk fractionation solution that provide customers with a versatile solution to meet market change and competitive landscape. With this multidimensional approach, SPX offers you a very flexible production tool that can adapt its product according to its current needs, but also for future development. SPX Flow strength is also the ability to provide end-to-end process and to boost wider portfolio. By the functionalization of the end product derived from this fractionation process as casein, which can be used for cheese or yogurt, whey proteins which can microparticulate and used in cheese and high proteins product, lactose to make lactose powder or gauze, until the last drop as salt, minerals to make sport drinks. So using advanced membranes technology to fractionate and concentrate the milk native components preserve the whole proteins, which allow us to maintain a higher quality proteins content while preserving the natural property and full nutritional value. This separation of milk components allows for the customization of a range of dairy products, creating a new world of possibility for you and can be used in various food applications, including sport nutrition, infant formula, and functional foods. So, by efficiently utilizing each component, you can tap into previously untapped markets. As mentioned earlier, milk ingredients can be manufactured in both wet and dry form. Here you can see key drivers for dry form as long shelf life, 8 to 12 months, reduced transportation volume, usable in distant location from the production site. Storage required less space to storing large quantity. Simplify storage, no need for large aseptic space, and lower building cost. Balance seasonal production differences. New market opportunities. Market opportunities in home and factories, suitable for retail pack and institutional sales. Dry mixing and over-customization option available. In the other hand, the wet ingredients have also a lot of benefits, like quality and functionality by simplifying process, improving fresh taste, and getting lean CapEx and OpEx. So better functionality for end application, better quality control, tailor-made end product, clean label, and specific nutritional value. We can have also cost optimization. Using fresh, wet ingredients rather than buying or importing powder at higher cost can save from 15 to up to 40% in your formulation. Innovative product with the perfect combination of taste and functionality. Concerning sustainability, it's sustainable because there is no drying, no mixing with water downstream. Manufacturing ingredients locally will save carbon footprint, time, and cost of importing. SPX Flow is worldwide recognized expertise in food and beverage process engineering. Our vast expertise in milk components and extensive knowledge in processing technologies and end application as fermented product, infant formula, butter set us apart in the market. With over 5 decades of experience in membranes filtration, SPX Flow has established a proven track record in providing reliable and efficient solutions to the dairy industry. Our state-of-the-art innovation center, notably the two in Denmark, serve as the epicenter for research and development. Here, dedicated process engineer labors diligently to refine the process technologies tailored specifically for dairy applications like membranes, heat treatment, evaporation, and drying. Combined with our comprehensive and tailored automation, SPX Flow can support you to build a relevant and consistent solution end-to-end process. SPX provides all key technology for end application, like UHT, evaporation, homogenization, spread and fluid bed dryer, mixers, valves, and pumps. These components are supported by SPX Flow full lifecycle approach concerning services and spare parts. We have also 3 innovation centers or develop labs to trials and test your product located in Denmark, Mamirol, and Shanghai. Our innovation center can help you to create customized product, ensuring they meet specific market requirements, thereby enhancing your product offering and competitive edge. We can welcome you to our facilities to try new recipes, or on many cases, you can rent equipment from this facility to test in your own factories and labs. Of course, we can also test the liquid food, plant-based in this case, for example. Our recent success story on this slide represents both possibilities, wet and dry ingredients, produced by SPX flow milk fractionation solution. Case story 1, it's a global leader in Spain, with the capacity of 1,340 tons per day of skim milk. With the fractionation process, they get dry product with MPC 60, MCI, WPI, lactose, and regenerate water through the process to be reused as dye water and CIP water. Case story 2, it's a global leader in France with the capability of 220 tons per day of skim milk. With our fractionation milk process solution, they produce liquid products like MCI, WPC 80, lactose, demineralized D90, and recover water for dye water and CIP water. So you can see that the benefit of milk fractionation extend far beyond improved product quality, providing natural, nutritious with enhanced functionality for end product. SPX Flow dedication to sustainable practice is evidenced in our consistent design for energy efficiency. By minimizing energy consumption while maximizing yield, the system is not only benefit the environment, but also translate to significant cost saving for our customer. This ends today's presentation, and I will now begin our question and answer session. Just a quick note, after we complete the webinar, all participants will receive a copy of this presentation and ability to submit a private question to me and my team. We welcome your question and commentary on your membranes filtration projects. Please give me a moment while I pull up our question.
We can take the first question now. So what is dye water and what is its role? So the dye water is used when you make a dye filtration. So what is the dye filtration exactly? So the dye filtration is a technique that's used to remove a low molecular weight solute, such as salt, from a solution of a high molecular weight, as here proteins. So the purpose is to wash out a maximum original buffer salt from solution containing proteins and other large molecules by this dye water. The advantage over the conventional method such as dialysis or column by gel is that with dye filtration, we can perform quickly and easily. Another big advantage also is with the dye filtration, the product is concentrated on the same system, so we can minimize the risk of the losses and the contamination. So the second question is, what quality of milk do you need to have to be able to do fractionation? The quality of the milk is essential for the milk fractionation process, since the goal is to separate and concentrate at each step. So that means that we will also concentrate the bacterial load. Therefore, if necessary, to achieve a minimum load in the feed, we have the option of using bacterial removal microfiltration as a first step to maintain a low level of bacteria before proceeding with the fractionation process. As here we want to preserve the proteins, of course we cannot use the harsh heat treatment. It is the reason why we use this microfiltration bacteria removal, which is a very gentle technology to remove bacteria from the milk. Okay, so there is another question concerning the in what case is the membrane used to remove the fat? Okay, so as mentioned earlier, for the main milk components, the membranes are usual in the ultrafiltration range. The ultrafiltration allow components such as lactose, lactic acid, and dissolved mineral to pass through the membranes. And at the same time, the ultrafiltration will concentrate fat and proteins. Therefore, to reach a high level of proteins concentration, like WPC80 or WPI, we must remove as much as possible the fat. And in some cases, the separator is not enough efficiency. And in this case, we use the microfiltration to remove the fat in the product. So there is another question: where is your pilot plant located? So we have 3 innovation centers, as I mentioned in the webinar, but the main one is in Silkeborg, Denmark, where we have all our wet pilot plant, including the membranes filtration plant. But of course, if you want to make it in another location, at home, in your facility, or in other SPX innovation center, we can send out our pilot plant. Sorry, there is a lot of questions, so I have to say a little bit. How milk fractionation is a green process. So when we talk about fractionation, so the environmental sustainability can also be aligned with economic valorization. So irrespective of the degree of fractionation, the fractionation process are accompanied by a range of environmental impact that arise when milk is converted into product with enhanced feature and a higher economic value than the non-fractionated dairy product. There is a lot of sustainability point during the fractionation process, so I cannot list all, but we can take a very simple example, such as the case of milk concentration. So the milk concentration represents the fractionate product here, and we will compare it to its non-fractionate counterpart, which is the skim milk. So as you know, recently fractionate milk concentrate were introduced as the substitute for milk powder, wherever a powder or reconstitute, such as in the production of yogurt, ice cream, or finished milk. So the skim milk concentrate, which required no energy and no energy to dry, were found to save up to 35% of the cumulative energy demand required for the production of the skim milk. What? Next question is, what filtration is best for concentrating WPC80 from 25% to its limit, and what is the maximum concentration limit for concentrating WPC80, nanofiltration or RO? What are the risky by going more than 30% in the dry matter? So when you want to concentrate the WPC80 up in terms of dry matter, of course, we will use RO and nanofiltration, knowing that during the concentration, your viscosity will increase dramatically. We can make the combination of both technologies, so reverse osmosis and nanofiltration, starting with the reverse osmosis, which is the tightest membrane size, and finishing with the nanofiltration to compensate the viscosity of your product. So here I can say that the main limit will be the viscosity of the product, but in the other hand, we always say that the limit is really the cost to remove the water. So as you know, inside SPX, we have also expertise in evaporation system. And to decide which kind of concentration is better, we try to balance both technology to see where will be the split point. So normally there is no limit in terms of concentration for the membranes filtration, except that more you have the viscosity, more we will need the membranes to compensate the low permeation through the membranes. So at a certain point, the cost to remove the water will be too high to compensate the payback in terms of concentration. Okay, so the next question is, what is the microparticulation technology? So SPX proposed two microparticulation technologies. The first one is the link trim system, and the second is the KV master system. It is two different ways to do microparticulation, but both is based on the same concept and principle. So SPX want to do this microparticulation in one step instead of two steps in the traditional way. So that means that we will make the denaturation of the whey proteins. In the same time, we will microparticulate it. The reason why we do it in one step is we get a more open and loose protein structure with a significant improvement of the functional property, and we provide also higher producibility. So it is a very powerful and amazing technology, because the result of microparticulation is that starting from a product that is whey proteins, having strong taste, flavor, yellow or dark color, you will get a product with a creamy mouthfeel, viscosity, white color, neutral taste, and in particular, it's a pure dairy-based ingredients, which can be used for various functions. So we have also a pilot plant to test the microparticulation. You can do it in our innovation center, or you can also rent, the pilot plant. Okay. Another question, is it possible to rent ultrafiltration from your facility in Denmark to conduct pilot trials? If yes, what is the scale size of your equipment? So yes, you can rent out the pilot plant, and we have two sizes of ultrafiltration. So according to your application, we can estimate by doing the mass balance, the capacity of the plant, because of course depends on your application. The cutoff of the membranes we will use will not be the same, and also the supplier will not be the same. So the capacity will change according to your application. So next question is, what are the regulatory restrictions in different geography for using fractionation product? So as I know, there is no geography restriction because we use it everywhere in the world currently. We have a worldwide reference, and I don't see where there is a restriction. But I can check it and come back to you to confirm if there is any geographic restriction to use a fractionation product. So next question is, does SPX also have any technology solution using ion exchange fractionation of milk? So yes, in this webinar, I just touched the first fractionation layers. We can go, of course, further in terms of fractionation. And in some case, we can use ion exchange or chromatography or electrodialysis. This technology is not in SPX portfolio, but we work with partnership, and we can also set up the full line to test in our facility, including external technology as ion exchange or chromatography. So next question is, what brands of membranes do you use for microfiltration, ultrafiltration, and reverse osmosis? So to reply to this question, we use different type of membranes. So we can use organic membranes, known also as spiral roots, or ceramic membranes. But you know that we are not producer of membranes element. We use the supplier from the market, and it is something very important for us to do like this, because we can choose and select the right membranes according to your application. So every year we make a screening of the new membranes to be referenced in our application portfolio. And then for each application, we will choose the most adequate membranes and supplier, because it's not, if you take, for example, the ultrafiltration membranes, does not mean that you will get the same performances from all suppliers according to your application. So we have this expertise in-house to really select the right membranes according to your application. So next question is, are there ready solutions for the concentration of whole milk? Yes, of course, there is already solution to concentrate whole milk, and you can do it with a reverse osmosis, and we can concentrate it for, I would say, different reasons. Mainly for transportation and reduce the carbon footprint. And we can make it also to replace in some time the evaporation system. So next question is, what technology is required to produce a WPI? Does ultrafiltration only enough? So it's a good question. When you mention WPI, it depends how you want to do your WPI. So you have two ways to do so from the milk directly. So it's a milk whey proteins isolate. So you get it from the ultrafiltration, and then we go up in terms of concentration. And you can make the WPI also from the whey proteins. The whey from the cheese process, sorry. And normally, yes, I would say the ultrafiltration is enough if we focus only on this step of WPI. But if you want to do, for example, the milk whey proteins isolate, of course, you need to start from the milk and remove the casein first. So that means that you need to have the microfiltration first to remove the casein and then concentrate the whey fraction. So what technology is required to separate casein micellar from whey proteins? Therefore, no need to make cheese to produce whey. Exactly. So it is what I mentioned. So you can I would say that until now, when you got your milk, you just say, okay, I have the milk, so I need to do a product. And then after I have to do, for example, cheese. And after the cheese, I will try to see how to valorize the subproduct. Here, in the fractionation, we don't think like this. I mean that we try to think outside the box and see what will be the best economic way to do and to use your milk. And here it's a very good question that yes, we can separate the casein micellar from the milk directly with the microfiltration. So you make the separation between the casein and the whey proteins. This casein will deliver better value compared to if you use it directly in the cheese, because it's a native casein micellar. But in the same time, if you want to make the cheese, you can use also this casein to make the cheese, to make the standardization of your cheese milk, I would say. It will improve the yield of your cheese process. And in the same time, you will get not the cheese whey, but the ideal whey. and the ideal way have more add value compared to the cheese way. You have more application with the ideal way because you don't have residue from the cheese process like a GMP. So it's a very, very valuable product compared to the cheese way. Can we use the same ultrafiltration to make WPC 80 and MPC? Yes, the membrane filtration is the most flexible technology. I would say that we can use the same plant to do a very large range of application. It's just to, I would say, know it during the sizing. So we can size and design the ultrafiltration to produce both WPC and MPC at different level of concentration. So it can be up to you from 50 to 80 to 90. And you can also use the same plant to make as a pilot plant using only one loop, so very small fraction of the plant to make as a pilot plant to test more product or to lower the volume of the production if you want just to make a very small quantity of product to make a new formulation or a new product. So next question is, what is the best type of filtration to extract the demineralized 90? You have two possibilities to make the D90, not two, but in terms of product. So you can make the D90 from the cheese way, and you can make also the D90 from the ideal way. Okay. So to make this D90, you can use also the electrodialysis combined with the nanofiltration. And according to your minerals profile, we can have also the combination of nanofiltration, electrodialysis, and ion exchange. So you have, when we talk about D19, you have a lot of kind of D19, and we need to understand which is the minerals profile you expect to get. So according to this mineral profile, we can provide the solution. So which combination have to be used. And as I mentioned to you before, we can set up the complete line trials in our innovation center, starting from the cheese way or from the milk, making the fractionation and then demineralize. And we can also dry it. So at the end, you get D19 powder that you can bring back to your facility to make analysis or formulation. How do you ensure the longevity and maintenance of the equipment used in milk fractionation? So the core activity of SPX is really to provide equipment with life cycles. So that means that we can provide services and spare parts to make the maintenance. and we can also provide guidelines or train your guy also how to make the maintenance of the equipment, and we can provide the guidelines in terms of the frequency of the maintenance of each equipment, as we are the manufacturer of the process equipment. Okay, so I am sorry, but we are running out of time now, and I cannot answer all your questions, but we will collect all of them and make sure that we get back to you quickly with the correct answer. So thank you very much for your interest and your attendees for today's webinar.